Welcome to Introductions to Proofs. This is probably the most pure form of maths that we're going to do at GCSE. So what is a proof? Well, a proof is showing that something is always true. So to do that, we're going to need to use algebra. We're going to come onto that in a few minutes. Firstly, we're going to say how we disprove something. So if a proof is when it's always true, all we've got to do is find a single case when it's not true. So let's look at a rule, the multiple of 2 primes is always odd. Okay, now we can find hundreds of examples where that's true. 3 times 5, 7 times 11, all of those, if we get a prime times a prime, we get an odd number. However, if we choose to have the numbers 2 times, 7, right, that equals 14, which is even. Okay, now 2 and 7 were 2 primes, they've made an even number, so we have now shown that the proof does not always work. Therefore, the rule is not correct. If it had said 2 prime numbers, neither of which were 2, then maybe it would have worked. In fact, actually the case is it does, but that would need proving, which is what we do next. So, for a disproof, all you have to do is find a single situation where you can find one thing that doesn't fit. If you find that, you have broken the proof, you have disproven it. Okay? This is much like the idea that if I said all animals have stripes, I can find a single example where that's not true. Let's look at, humans. Humans don't have stripes, therefore all animals do not have stripes. Done. Now, a very important concept there is that was disproving, but we could find a single situation. Proving you can't. And because you can't, that means you either have to test every single possible situation, or you have to do it purely algebraically. So, in maths normally, if we're just using general numbers, then you would not be able to do it for every single situation. If you had a room full of people and you said every person in this room has red hair, you could look at every person in the room, including yourself. If every person in the room has red hair, then you are right, because you have actually checked them all. We can't normally do that mathematically. Okay? So, we often deal with odds and evens. So an even number, we need an algebraic way of writing that. Well, an even number is any number that has a factor of 2 in it. So it's 2 times something. 2 times n, where n is just some number. And when you're counting, numbers go even, odd, even, odd. So an odd number is just one after an even number. And to stop them being just the numbers next to each other, so for example 2 and 3 or 6 and 7, we're going to use a different symbol, 2m plus 1. Now this is because n and m are general numbers. If we double them, and they're whole numbers, if we double them, they'll make an even number. If we add 1, they'll make an odd number. And n and m can be any even and any odd number. So, let's look at the following. Odd times an even makes an even. That's a statement we use a lot, but now we're actually going to be able to prove it. Okay? Odd times even equals even. Well, odd was 2m plus 1. We're going to times that by even, 2n, and that makes 2, in fact I've times it all out, mn plus 2n. We can take a factor of 2 out of this. It's 2 mn plus n. Now you might correctly notice we could bring an n out of this, although that would be good for factorising. That's not actually what's important here. So if m and n are whole numbers, that's a whole number. Therefore, this equals 2 times some number k, where k equals mn plus n. So that's even. Okay, now, we didn't need to write k here, right? This is just me trying to make it look very much like that, because remember, n could be any number. K is just, again, some number, which we've got out of that. Right? So all I'm saying is that it's 2 times a number, therefore it's even, because 2 is a factor of it. So you have now proven it. And if you want to get a little bit of lingo, QED. That's what we write after a proof, or I write as required. But QED is technically the best way of doing it. So that is an example of a proof. So when it asks you to prove something, what you need to do is put it down algebraically. So even numbers, 2n, odd numbers, 2m plus 1. There are lots of different ways that the question can ask you. And you need to change all of those into algebra. You then bring it together algebraically and get it to solve, remembering this. Okay? Now remember, a square number would just be k squared. And yeah, that's about it. Okay? I could prove that an even number plus an odd is an odd. Okay? Something similar. Even plus odd equals odd. 2n plus 2m plus 1 equals, well, let's bring it together, 2n plus 2m plus 1, 2n plus m plus 1. Right, now n plus n is just a number, so this is just 2 times some number plus 1. Right, so this bit is even because it has factor of 2, therefore this whole thing is odd. And again, proven that algebraically. I hope that makes sense to you all.